So, gentlemen, I bid you welcome to the shop again. As said in the previous video, I'm sorry for walking over the place, I'm ashing the cigar. As said in the previous video, I was going to post a video that I was editing, but I have decided to scrap it. This is the fifth take. I have just taken the fourth take and I have been rudely interrupted and pissed off. So, yeah, let's go for the take number 5. I have actually prepared the initial sketches and some of the designs that I have for the Weisser mill modifications. I will try to keep it as short as possible, but there's almost no way that this video is going to last less than 50 minutes. So, some of the Weisser componentry has been removed. The rest of the machine is still outside, the base and the column which is attached there too. The motor, the CVT, and well, the belting that attaches the CVT to the spindle, or rather transmits the drive into the spindle, has yet to be dealt with, and the two parts have yet to be ground off of the paint and, well, crap, junk, and the rest of scum that I do not want to bring into the shop. The table has been removed. As you can see, it has been sanded along the periphery to alleviate some of the casting imperfections and some of the angle grinder marks which were generated by the, well, as a result of initial casting fettling by the Weisser themselves. The modifications that I am going to impart onto the machine are mostly going to be bearing system modifications for the shafting and for the gears and everything, because all of the shafting relies on the cast iron bores and shaft steel as bearing solutions for, well, the shafts. The gears are riding with gear steel against the spot faces. All of those are really durable solutions, and all of those are really shitty solutions, because once stuff wears out, it is really hard to properly repair, because you no longer have proper geometry nor datums to go off of and to re-establish, or rather to even try to establish the proper location for the bores and for the spot faces and for anything. The shafting, or rather the feed screws, lead screws, however you want to call them, are in nearly virgin condition. I can only show you this one because my back hurts as fuck. This is the Mini-lathe lead screw, the middle one with the bronze hand wheel. This is the knee actuation screw. This is the X-axis table screw for the Weisser, and this is the Y-axis feed screw. All of the screws have either one or two, well, only the table screw has two axial thrust bearings. All of the shafts have a radial bearing provided as said by the bore and the shaft steel. All of the bores are going to be machined. They will be, well, not all of them. The table chunk over here of cast iron is going to have a bore passing through it and a radial needle bearing inserted into it. There are going to be two small low profile O-rings inserted into the bore as well, which are going to provide elastic location against the two fixed races of the thrust bearings on either end. So there's no need for it, because the radial bearing, while it cannot cope, the needle bearing, it cannot cope with thrust forces. All the thrust is alleviated by the, well, thrust bearing at the front and in the rear. Some of the shafting is going to be modified, reduced, merely to allow me to not have to modify the bores too much, or rather to minimize the amount of cast iron that has to be removed. All of the spot faces that have to be regenerated, or rather all of the spot faces will be regenerated, except the ones that have the needle thrust bearings or other ball bearings touching them. For example, the knee spot face from below, which you cannot see, that has the ball bearing, the thrust ball bearing riding or rather pressing against it, is supposed to be unmolested and so it will not need any regeneration. The machining of the bores is going to be done with custom boring bars. They're going to be of a stepped design, essentially like a bolt. Let me, this will do pretty nicely. I have picked them out of one of the a certain machine shop's scrap bin. Imagine that this is much longer. Imagine that this perfectly fits, for example, for fuck's sakes, this bore over here. The boring bar will be fed into the bore as first, so the rear end is going to be inserted into the bore. A high-speed steel nib is going to be fed incrementally with each cut outwards. The unmachined section of the bore is going to provide bearing the same way it does for the shaft for the boring bar to negate all of the chatter and to provide the location for the boring bar itself. A hard shoulder is going to be machined atop of the boring bar, or rather the boring bar will be reduced from a larger piece, and a hard shoulder is going to act as a stop, as a positive registration surface, and that will ensure that the bore is cut to the same depth with every pass. The depth that each bore will be cut to is going to be dictated by the radial needle bearing that is going to be inserted into it. A small low profile O-ring is going to be seated atop the, well, this radial needle bearing at least, and the spot face is going to be regenerated as well. The gear that was riding with its face against this cast iron spot face over here as a bearing solution is going to be slightly shortened. A thrust needle bearing, because thrust needle bearings are lower profile than ball thrust bearings, is going to be placed between the two, sandwiched, and it is going to compress the O-ring, and it is going to provide some, again, elastic location registration for the radial bearing inside of the bore. So there's no need for it. As said, all of the thrust is taken up, or is going to be taken up, by the pairs of thrust bearings, but why not? Why not? There's no reason to not insert a small bearing. So that deals with the boring bar design. The boring bars are going to be hand pulled inside of the bore, and the drive will be provided with a hand drill. So yeah, that is the bore modifications. The knee actuator is going to receive the same modifications. As you can see, the gear is pinned to the shaft. The shaft rides, or rather has the radial support provided, well, shaft steel against the cast iron bore. A boring bar, a really long one actually, is going to be generated in the same manner. The boring bar is going to be pulled inside of the casting, or rather the casting is first going to be slightly shortened, remachined to fit a needle thrust bearing, yet again because needle thrust bearings are lower profile than ball thrust bearings, to deal with this improper bearing solution where the gear rides against the spot face of the cast iron. The casting is long enough. Nothing, no location of the features is, or rather are, the locations of the features are not going to be impacted by the modifications. Nothing is really going to impact anything except a proper bearing solution will be generated for every shaft, every gear, for everything. I believe that there's a axial ball bearing hidden inside of this dial, as one was hidden inside of the, well, the dial, which you cannot see, for the table, and I believe that one is hiding inside of the dial over here for the y-axis. The knee has essentially been touched upon. There's a thrust ball bearing on the underside. The knee sits atop it, and yeah, that will need no real modifications except change of the bearing, because that one is old and crummy and cruddy, so it's going to be tossed out. A new one is going to replace it, an identical bearing, ball bearing. I believe that a thrust bearing would be needle thrust bearing would be a better solution, because needles have a much larger surface than the balls, and can deal with, can cope with forces better. But since the system is designed to fit a ball bearing, changing the ball bearing for the needle bearing, as said, lower profile, would require me adding a hardened washer to make up for the lost thickness, height of the exchanged bearing. So, reduced casting length, axial bearing, needle bearing over here, ball bearing over here, axial one replaced. This piece, as you can see, I speculate, can be removed, unthreaded, whether it is cast iron or machined steel, I'm not sure. But the two are going to be separated. A boring bar is going to be pulled into the casting after it has been shortened. A stepped recess increased diameter bore is going to be generated to fit a radial needle bearing in this side over here. One is in the same way is going to be generated in this side over here, and one radial needle bearing is going to be inserted into this piece over here. So 3 radial bearings are going to provide bearing support for the shaft. Axial bearings, ball, needle, are going to provide thrust support for the rest of the system. The gear, as said, shortened, spot face, regenerated, needle roller bearing thrust one is going to be put here. Radial one plopped into a enlarged diameter recess with a hard shoulder. A low profile O-ring is going to be compressed, or rather squished, with a needle thrust bearing that is going to be sitting between the gear and you get a point. So that deals with that, The gear has been touched upon. This gear is going to be unmolested. It is going to be pinned back in place, yada yada. The half nut, as you can see, is a half nut, as I have been speculating. That was a decent speculation. The half nut actuator with its 2 eccentric slots. It has a crescent gear cut into it. There's the actuation lever that's still screwed into the, let's call it an apron. The actuation lever still does not move. I've got no idea why. Everything has been taken apart. There's probably some kind of a positive registration hard stop, so I have not been trying to actuate it by force. Everything will have to be cleaned. No modifications will have to be done to these bits. The gibs will merely require cleaning, and maybe these two. The simple taper gibs will require some slight resurfacing with wet and dry sandpaper. The compound taper gib for the x-axis for the table is going to require nothing except for a slight cleanup. So that deals with all that. The lathe we're not going to be touching upon yet. The shaft, the feed screw for the y-axis that I'm, as said, not going to be showing to you. Also, I believe has a ball thrust bearing hidden inside of the dial. There is no thrust bearing on the other end. The hand wheel, as said, like all the other hand wheels, is retained by a taper pin. There's a steel collar that you can see over here, which is also retained by a taper pin and which provides, like that gear, a thrust bearing solution, no real thrust bearing, plain thrust bearing solution against the spot face over here on the back end of the bore. That the collar will be tossed into the garbage, and another one will be remachined. It will be a telescoping threaded design with a locking nut, with a lock nut. I will simply put a needle, or maybe, why not, a needle thrust bearing against the spot face. I will regenerate the spot face as well. The telescoping threaded collar is going to preload the bearings, and that's pretty much it. It's going to be locked in place with a lock nut, and it's going to be pinned in place beforehand. So that deals with that. The bore is also going to be remachined in the exact same manner. I will pull a boring bar from, it will be inserted into this hole, into the bore. It will be pulled through the bore, not all the way through, leaving a hard shoulder in the rear. A radial needle bearing is going to be inserted into it. The shaft will require no real modifications. Also, this cast iron piece is going to be machined in the same manner because it is a compound plain bearing. The chunk, this piece essentially, which has been removed, has the shaft riding inside of it, and the bore as well supports the remainder of the shaft. I'm going to machine a recessed bore with a hard shoulder over here for one radial needle bearing. This section is going to have a recess cut from this way with a hard shoulder in the back-to-back configuration. Essentially, a hard shoulder will be left over here, and the hard shoulder will be left in this segment that butts up against the knee over here. So two radial needle bearings, one needle thrust bearing butted up, or rather preloaded by the collar, the other radial ball bearing hidden inside the dial. Of course, all the ball bearings are going to be replaced. And that pretty much does it. I covered the modification for this table bore. It's going to be bored through. A needle radial bearing is going to be inserted into it. Two O-rings, two thrust bearings are going to be setting it in place with the help of the O-rings, which are going to merely take up the slack, or rather the free space. And that is pretty much all the modifications regarding the bearing solutions for the Weisser mill. The oiling, for the most part, is okay. This gear is going to be receiving, imagine this container for the oil, the oiling can. A bore is going to be made in a piece, a cup is going to be generated, which is going to have, imagine if you cut this like a crescent, leaving the mouth intact. You cut a crescent out of it, for example, with a with an immense sand mill. You know what I mean. Those crown drills, but not a crown drill. However, they're called. I cannot remember the name at the moment. It's going to fit over the round section of the casting, and it will retain an oil bath. It will keep an amount of oil that the the gear is going to lick and apply onto the other gear, so the gears will be in a constant oil bath essentially. Or rather, we'll have lubrication provided by a bath of oil that this gear is going to be wicking and licking oil off of and applying onto the other gear. So the gears will also have a slight oiling modification, because as they are currently, you're supposed to, well, 1955, reach from underneath and brush some grease onto the gears with hand, which is retarded, and I do not feel like doing it when I can apply a simple piece that can hold the oil. This, how do you call it, way surface for the main column dovetail, as you can see, has no oiling solutions. It has a really nice cast-in hole over here, which is going to be bored, or rather turned into a stepped bore. The wall thickness is some 15 millimeters or so, half an inch, let's call it. A stepped recess is going to be cut into the bore, so a stepped bore is going to be generated out of this hole. A stepped plug fitting that stepped bore is going to be inserted into it. It is going to be slightly shorter, so it is not going to be in contact with the column. It is never going to contact the column. Well, it can contact it, but it will have no force pushing it against the column, and it will be slightly recessed. A hole is going to be drilled through it. A hydraulic hose is going to be piped through it. A common rail casting off of a diesel engine is going to be inserted and mounted over here inside of this casting, and it is going to supply oil to this plug. The hydraulic pressure will provide all the seal, and the viscosity of the oil will provide all the sealing, along with a labyrinthine nature of the stepped plug and the stepped bore. And that will feed the oil to this surface. A rounded groove is going to be cut across the hole, or rather across the bore, and two rounded bores will essentially triangulate the oil passages, which will terminate over here at the top. These are not cracks, these are just well, trash and scum on the surface, allowing the pressurized oil to feed outwards and to push all the way over here, showing me that, well, wicking and climbing over this non-bearing surface, and ensuring me that everything is properly lubricated. The small recess, the non-contacting plug, is going to provide a volume of oil that is simply going to be able to wick down. So yeah, and to climb up if the knee is actuated downwards, the oil is going to simply wick upwards. So that is going to provide an oiling solution for this surface. The dovetails will receive their own oiling solution. I cannot extend the oiling grooves into them, because then they would just piss oil downwards through the grind relief, let's call it so. So this dovetail here will have to receive its own oiling solution, and the gib is going to have to receive its own oiling solution. I'm not sure which approach I will take, but I'll think of something. That shouldn't be all too hard to think of. The ways for the apron are oiled by the apron itself, so that is no problem at all. The table has its own idiotic oiling solution that I cannot show you, but it has two oils, two oils. Oh, for fuck's sakes. Two holes drilled through the bottoms of the T-slots, which have, anyway, you have seen it. It's not bottoms of the T-slots, I'm going nuts, but in the bottom of a T-slot there is a drilled hole with a small screw which oils the driver system for the lead screw. I will show you the footage, you will get what I mean. That is why I said the bottom of the T-slots. The table has two holes drilled into the tops of the T-slots, which you simply unthread screws out of. You drip oil into them and return the screws into them. Essentially the same way that the shearer lathe provides oiling for this, well, bearing inside of the taper cutting attachment. You simply unthread a screw, you drip oil into it, and you put the screw back in. Speaking of which, I have been oiling it today, so given that the oil has nicely found its way in there, to prevent any scum from falling inside, I will return the screw back into there. So I believe that I have covered all the oiling and bearing modifications to be done to the Weisser mill. The reassembly of the machine, I believe I have covered as well. As said, the base and the column are going to be dismantled. The stuff inside the motor, the CVT, the belt, are going to be taken out. The base is going to be rolled through here, merely to not have to bother with moving all the machinery outside and to cram them all back in a single day. It is much easier to just roll the base on a wheeled plate, essentially. How would you call it? You know what I mean. Inside over here, the bottom for the feet, the places that the machine feet are resting against, are going to be lapped. The machine feet are going to be placed to support the base, as I want to have some slight access from below, so I can lift it up again once I build a proper machine shop. The column is going to be plopped atop it. The geometry is going to be established because, as said, I believe that I have said it. I've got no idea. I said this is the 5th take, so I'm losing my shit. But let's rush through it again. The knee has a screw going into a nut. The nut is fixed. It has a spot face and the bore that it fixes into. That spot face is supposed to be parallel with the surface that's in the base, on the base, that the column mounts to. That spot face and the surface being parallel also have to be square with dovetail. From then on, the rest of the assembly, once everything is insured, match scraped, or not match scraped if it is not needed, once everything is derusted and the geometries have been insured, the reassembly can begin. So, with all of those bits done, with everything properly settled and dealt with, we can move on to the modification that is called the Weisser vertical mill head ISO 40 taper. This is just a rough sketch. You have seen the machine column. The head is going to have, as you can see, a recessed section. The vertical spindle, the horizontal spindle is going to feed inwards over here. You can see over here a bore that is going to have a shaft and a gear, and a bearing supporting it, passing through. Those will actuate a bevel gear inside of the head. The bevel gear is going to have its own separate. These are just rough sketches and drafts, so never mind potential changes that are to happen. Shaft, bevel gear 1, bearing support for it. Another bevel gear which is going to have its own sleeve that is going to ride in its own bearings, as not to influence the spindle, not to cause any distortion to the spindle by the drive mechanism. So the gear is going to have a essentially, I'm not going to explain it too much, but 2 bearings. The bearing system is going to change. I have decided to use angular contact bearings in the bottom over here at the top, instead of tapered for fuck's sakes, needle roller bearings, radial and axial for it. But you are going to see the design once everything is done. As you can see, shit is crossed out. It's simply going to be one massive bore, 130 millimeters, 13 centimeters diameter, for a angular contact bearing at the top, the sleeve, the gear, driver gear from the horizontal spindle, bottom of the, how do you call it, for fuck's sakes, sleeve, another axial ball bearing, another axial ball bearing for the spindle. The spindle will pass through the sleeve. As you can see, the spindle is going to be reduced from what is it, I believe 90 millimeters to 50 millimeters passing through the sleeve. It is going to be either keyed or splined, and the sleeve is then going to be splined or keyed to, of course, match the spindle design. Another how do you call it, axial ball bearing. You can see the ball bearings mentioned over here. NSK, I just picked them as examples. NSK 45, it's not going to be 45, it's going to be 55. No, it's not. It's obviously not. I might have gone a bit mad, but one NSK 45 by 85 by 19 at the top, a clamping backplate retaining the bearing, and 4 NSK 85 by 130 by 22 millimeters. 1, 2, 3. I wanted to put another one over here, but it's not going to be 4, it's going to be 3 NSKs. So 3 large axial ball bearings, 2 for the driver sleeve, driver mechanism sleeve, 1 for the spindle, and the smaller one for the spindle in the rear. I'm sorry, the focus has gone out. And the head is going to mount to the column via 4 bolts, via 2 locating pins, and it is going to have 2 brass compound taper gibs that are going to locate it against the flats of the what the dovetail terminates in. I'm going to insert the photo of the machine so you're going to be able to see it. So that's the vertical head. It's going to be fucking huge, as you can see, 27 centimeters long, 17 centimeters wide, extending to 19 back, terminating over here to fit the boxway. Essentially, it's not a boxway, it's simply a square surface. As said, I'm going to insert a photo of the machine if you do not recall it. Let me just... Whoops! The fuck is this? Oh. There we go. This is another... This is one of the preliminary designs for the Weisser head spindle driver sleeve, essentially bevel gear, but things have changed. I have worked on the design. This is some of the rough sketches of the rectangular, or as I like to call it, square section of the Weisser front face. As you can see, the dovetail is extending from here and is a bit wider, but this is reduced 13.5 millimeters across the length of it from the top to where it starts extending into the dovetail is 18 centimeters, which is why, yeah, anyway, you have seen, where the fuck is it? The head going, as you can see, the casting looking somewhat organic, and I have started drawing it too low on the page, but it is going to have a similar organic slope shape in the bottom to accommodate all the crap that it has to have. Where the fuck is where's the rest of fuck wait, give me a second. And this is the other modification that I want to do. This apron, as you have seen, has a bore passing through it. The table has a rack mounted to it. Given that it has a half nut, I believe that Weisser intended you to essentially release the half nut, use the rack and the gear mechanism to drive the table back, actuate the half nut yet again, have it drive forward. This it automatically declutches the half nut. You drive it back with a hand wheel and no, gear and rack, and simply you have a semi-automatic drive where you are part of the return stroke and the machine drives the table again forward and again and again and again, declutching every time it reaches the mechanically set declutching point. But this is the back part. So the table, the actuation handle for the half nut is over here. So this is the back side. The mill column dovetail is over here. This is the back side of the, for fuck's sakes, apron. There is a bore passing through this section. You can see a slot for the gear over here. I intend to machine a piece that you can see which fits the 32 millimeter bore extremely precisely. It is going to have some bearings, as you can see, radial needle, angular contact ball bearing, a back cap merely to prevent scum from falling in. A shaft is going to pass through these. A hand wheel is going to be added to the top of it, pretty much the same way Weisser wanted you to actuate the table. This is the table is the hand wheel for the table is over here. This is the front side of the machine. Let's then change over like this. You have the handle. You are supposed to move the table back, actuate the feed. The table moves, declutches, you roll it back, and again. So that's not going to be happening. This is not a design to accomplish that. This is a analog readout design. This houses the bearings and allows the shaft, which is going to be turned out of a hammering drill bit for the stone, chisel style, which has a I will insert a photo of it so you can understand, because it's the fucking ideal design. The length fits perfectly, the width fits the bearings perfectly, and it has a mushroomed section in the middle which can be turned down to fit a gear and to have a gear keyed onto it without meddling with the shaft. So it's a really nice piece of stock, and I have them in abundance. So yeah, it's going to have a hand wheel attached to it, a dial, a clock spring, a very strong clock spring, essentially a quill spring, and I have a few of those as well. The gear is going to be in constant contact, preloaded against the rack of the table, so it's going to be trying to move the table back all the time, but that's not the point. I don't really give a fuck, because if the half nut is closed and engaged, it is also going to be eliminating some of the free play in the backlash. But the point is that this is going to act as a, as you can see, a supposed vernier scale, a supposed dial. It's going to act as a backlash compensating, or rather backlash eliminating analog readout, which is going to allow me to face the milling machine this way. I will be able to actuate the Y feed with the hand wheel. The knee actuation is over here, and the dial will be over here. The, how do you call it? Son of a fucking bitch. The analog readout is going to be over here. So I can feed the machine. I don't have to bother trying to read the fucking dial over here, the scale. I can simply feed the table, and I have a really nice big chunky dial, which is going to show me the position of the table, akin to the well, digital readout, but it's going to be an analog one. The thing that you have on those precision jig borers, jig grinders and stuff like that. So yeah, that's pretty much the idea. And as said as well, it is going to be eliminating the backlash of the screw, because it's going to be constantly trying to pull the table in one way or another. I will see which way I will preload it. So yeah, that pretty much covers everything. I have been rambling non-stop for like 42.5 minutes. I hope that I haven't bored you to death. I hope that you have been able to keep up, and that I haven't molested you mentally or auditorily. But yeah, those are some of the designs and modifications that I want to implement into the Weisser mill. You can see, for fuck's sakes, NRB stands for needle roller bearing, or you could say needle radial bearing. It doesn't really matter, because needle and the roller is essentially the same thing. ACB, angular contact bearing, 17 by 35. ACB, 17 by 35. 52 diameter of this mushroom, and 32 millimeter to fit the bore. As said, I will insert the shot of the machine. This is the bearing retainer over here. The back cap is also going to act as a bearing retainer over here. It is going to be lapped against a piece of glass and a sheet of sandpaper until it will rest flush with the surface while still retaining the bearing, although I might just add another o-ring, a groove for an o-ring, which would secure, or rather preload the bearing, keep the outer race squished inside of the, yeah, you get the point. The cutout over here that you can see is merely for the shaft and for the nuts that are going to be, it's not really up to scale, but you get the point essentially. And yeah, that I believe concludes the incessant and unstoppable rambling about the Weisser mill modifications. These are mini-lathe modifications, but I'm really not going to start those. I have a chunk of cast iron. You can see the I say that I'm not going to start, and I start carriage cross slide. I have a chunk of cast iron that I'm going to turn into a new cross slide. This one is rather anemic, and the chunk of cast iron that I have is 4 centimeters tall, thick, however you want to call it. It has to be machined. I have elected to use a something that I cannot show you because it's a boring bar inside of this piece, but a boring bar with rather large, and they are not DCMTs, but however you would call them, I don't see. But DCMT variant for aluminum, huge piece. It allows, well, the head can be tilted. The boring bar is of such a variant, not like this one. It's for fuck's sakes, focus on the boring bar. Damn shit. No focus. Okay, but it's square to the table. So the head, once tilted slightly, will allow me to generate a dovetail with a single point cutter. Being made for aluminum, it is going to cut really nicely. Being a single point cutter, it is going to cut really nicely, and being 16mm thick, the shaft diameter, it is going to be more than rigid enough. I'm not going to be shortening it. I know that I should. It's going to have a large stick out. I don't give a fuck. It's going to be more than precise enough, probably more precise than the original piece. I'm sorry. I'm turning into a pig because I'm overheating here. The compound retainer nuts, as you can see, nuts, bolts, have a crescent design which fits into this rounded groove. A really nice design, really thoughtful, trying to achieve the ultimate compromise between material given in this rigidity and everything, but it's a crap design. And it's a bit too anemic. It's not. I could modify it. I could simply plop a solid tool post onto it. I could drill a few holes and fix it. But I'm going to be generating a proper huge fat fucking slab of cast iron that is going to be replacing it. It is also going to be longer, which is really fucking nice because I do not like having exposed ways. So yeah, I know, the longer it is, it changes the wear pattern. I don't give a fuck. I can simply retouch it when I have to, and I can modify it to have much better oiling. So yeah, I don't give a fuck. It is also going to improve the rigidity. The the carriage is going to get a huge slab of cast iron, 6. It's going to pass underneath the ways, the bedways, and it is going to eliminate the need for these small chunks, the retainer plates, which serve actually no purpose on this side because the carriage is trying to tip away from me, not towards me. But the back side is also going to receive its own modification, all of which are going to be large, nice chunks of cast iron, which are going to pass underneath the bed. They will have a compound taper cut into them, again with the same boring bar at a different angle of the head, and they will receive a nice bronze compound taper gib, which is going to ride really nicely, have full contact along the underside, unlike these small chunks of shit which barely even contact the bedway. So that is going to allow a much nicer bedway underside wear pattern, at least on this side, because this side, the set doesn't really wear or nor get any contact due to the forces trying to, you get the point. Yada yada. Strengthened carriage, strengthened cross slide, the cross slide being thicker and larger. It is also going to grant more rigidity to the system. And the solid tool post is going to also add more mass and stiffness to the whole assembly. This piece will also be remade because this is yikes. The tailstock is going to receive its own modifications, but I'm going to shut up now because I have rambled on for far too long. I'm also considering maybe replacing the headstock. I wanted to have it recast, but we'll get to that eventually. I do not want to talk for another hour and a half. The hand wheel that, that I plan to use to exchange this original one for will be used. It's a really nice idea that and the design that I managed to work up to so far, and I have stopped with the modifications apart from the disassembly. The Emco herself will have to be inspected for As said in the previous video, the quill is slightly sticky. You have been able to hear the tension in the system. You cannot hear any scraping, as said, if the driver gear has bitten into the, well, outside of the rack machined area. It should be scraping along the whole length of the stroke. If the shaft was bent, the sticky point, or rather the sticky segment, should repeat with every revolution. Neither is the case. I don't know what's exactly the problem, but none of that really matters at the moment. And the point is that the head slightly nods improperly, so that will have to be sorted out anyway. As said, the spindle will also have to be re-greased properly, so yeah, I have some maintenance to do over here. And that will, I believe, conclude this video, because the camera is overheating in my hand. It's not just that the room is too hot for recording for me, it is also not really doing the camera any favors either. The rotary table I'm not even going to get into. It's a, well, not an integral part, but it is an integral accessory, a foundational accessory, maybe better said, of the Thiel Contour-X, but I'm not even going to touch upon it. It's a really nice piece. I don't like the two-piece design, but at the same time, you have to assemble crap into it somehow. So yeah, it is the way it is. As said, not touching upon it at all. Yeah, so bye-bye. Just kidding. Gentlemen, this will do it, I believe. I bid you all the best. I hope, as said, that I haven't molested you too much and made you regret your life, nor opening this video. I'm going to update you on what comes first, when it comes first. The Habeger will continue to be slowly disassembled and yada yada. I believe that I will deal with the mini-lathe first, because I really have to have a functioning lathe, and I currently have no functioning lathes, despite having a lathe underneath and another lathe in the bottom. The Krusik lathe has been removed from my projects list. I will use that bed as a source of cast iron for recasting. Perhaps when I decide to recast this piece. I despise this design. The ears for the dovetail are far too anemic. I want to recast the bed, the knee. It's going to be in the identical design. I will give it all the same features that I will give to this one, but the ears are not going to be ears. They will be the same design that the shop-rant behind me has. A massive slab of cast iron going all the way, so no ears, just continuous slab of cast iron that cannot break. These ears have a tendency to break off on every machine that has this identical idiotic design, where the ears are essentially anemic little chunks of crap, which once you have a serious crash in the conventional cutting way, where the cutter is feeding from the back, or have a serious crash in a climb cutting direction, where the piece is cutting the front of the, where the cutter is cutting the front of the piece, it simply racks the table. Well, it tries to do so. It cannot rack the table because the dovetails are too strong. The cross-slide dovetails are too strong to allow it. So the weakest point automatically becomes the right-hand side dovetail ear, and it simply shears off, cracks off, and allows the knee to rotate and pivot out of the way. That is despicable. I do not want to allow the machine to be condemned to death either by my idiocy, should it happen, or by someone else's idiocy, should I happen to pass it, well, which I will, because I'm not immortal. I just wanted to say unfortunately, not really unfortunately. When I pass the machine to somebody worthy of taking care of all of my machinery, which will eventually get passed onto a worthy white child at some point in about 40, 50, 60 years. It really depends when my body will start showing signs of proper wear. I will of course mentor them until my last breath, and I will be with them to impart all the wisdom that I can, that is generously and freely imparted onto me by Robin, Stefan, and the rest of wondrous people like what's his name, Tom Lipton, and the crew. So yeah, somebody will eventually inherit them, somebody worthy. They will get them for free. I do not want to sell them. I'm not maintaining them and taking care of them to make profit from it eventually. I do it out of love and because I have found it to be my calling in life. So yeah, this is going to be recast. Nice slab, the same modifications, the same geometry, everything, but impervious to damage and impervious to idiocy, the same way that the Shoblin is designed. So yeah, gentlemen, I believe that this concludes the rambling. As said, Krusik is removed from the projects, but I really need a lathe as soon as possible. So until I start fiddling with the lathe again, or rather machining the piece that is going to replace this cross slide, I do bid you all the best. I hope that I made this video at least somewhat enjoyable to you. And until the next time, see ya. Bye bye. Enjoy yourselves.